Assalamualaikum and hi. So I'm from 3 BMMV S1/1. My name is Megat Iskandar. So we are going to explain the simulation of the structural, fluid flow, and the thermal on any mechanical equipment.
Hi, Assalamualaikum. My name is Muhamad Haziq. Today I want to talk about what is a CFD. So CFD is a simulation of fluids engineering system using modeling, which is a mathematical physical problem formulation and numerical methods. CFD made possible by the beginning of digital computer and advancing with improvement of computer resources. And what I want to introduce about our product, which is a ball valve, which is a flow control device which use a hollow perforated and pivoting ball to control liquid flowing through it, and it's open when the ball's hole is in line with the flow inlet and closed when the pivot 90 degrees by the valve handle blocking the flow. And the advantage of the ball valve is they can provide leak-proof service, open and close quickly. Other than that, when compared to the gate valve, the ball valve have a very small dimension and lighter than gate valve. Thank you.
Hi, Assalamualaikum. My name is Nik Ahmad Nazran bin Nik Ahmad Khan. I will explain about the first computational fluid dynamics simulation. The material selection for the first simulation, we used steel AISI 304 for the settings where relative mesh size is 0.05, curvature refinement parameters was turned on, curvature angle is 25 degree. Next, the curvature mesh size factor is 0.9 and the mesh growth rate is 1.0. And lastly, the maximum sweep angle is 45 degree. Next, in the figure 2, as you can see here, this is the steel ball valve in the green color, and for the figure 3 shows that the selection of material. Next, we move to time step graph for steel material. The line in purple shows the pressure, and the green line indicates that the velocity. As you can see here, the velocity fluctuated about to one value and then constantly declining, and the pressure is also constantly declining. This graph shows the time step about 25 seconds. Next, we move to velocity and pressure. In the figure 5 shows the velocity. As you can see here, the red color in the middle of the ball valve shows the maximum velocity, which is about 3.837 exponent 4 meter per second. And at the inner and outer of the ball valve indicates that the minimum velocity, which is about 0 to 1.279 exponent 4 meter per second. Next, we move to figure 6. This shows that the simulation of pressure. As you can see here, the red color, which is this and this, shows the maximum pressure, which is about 1.121 exponent 9 Pascal. So as you can see here, the blue dot you can spot here, which is the minimum pressure for the ball valve, which is about 7.973 exponent 8 Pascal. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Khayrun binti Karul Hamidi. I am going to present about the second computational fluid dynamic simulation. For this model, we have set the parameters of this model as same as the first model before. So, for the material, we have used the titanium alloy for this model. For the parameters, we have set the relative mesh size as 0.05. For the curvature refinement parameters, we have set it to be on. For the curvature angle, we have set it to 25.0. For the curvature mesh size factor, we have set it to 0.9. For mesh growth rate, we have set it to 1.0. For the maximum sweep angle, we have set it to 45.0 degree. The flow rate for this valve is 5.0 kg per second. Before running the analysis, we have changed the material for this model. This model's material is changed to titanium alloy. The selection material have been done through the Inspire software. After the material have been changed, we have imported the model into the AkuSoft 2017 software, allowing us to do the analysis. The result for the AkuProbe graph, which is the time step graph for titanium alloy material, can be seen here. There are two legends that appeared on the graph, which are velocity and pressure. For the pressure, the graph started at the highest peak and decreasing slowly as the time increases. However, for the velocity, the graph increases rapidly to the highest peak and drastically drain as the time increases.
Hello, my name is Nur Shuhada binti Kasri with matrix ID B0919100078. So today I will present about the second simulation which will occur velocity and the pressure. So here at the velocity figure, we can see that the maximum velocity was occur at the inside of the pipe, which indicate 4.985 times 10 in the power of 4, and then at the outside of the pipe we have zero velocity, which is the minimum value. And then next, this figure shows the pressure. So at the outside of the pipe is the maximum pressure, which indicate 1.695 times 10 in the power of 9. And this blue side is the minimum, which indicates 1.153 times 10 in the power of 9.
Okay, as a conclusion, by undergo the CFD simulation, we can solve three complex flow. The first one is the accurate numerical methods. The second one is the powerful turbulence modeling CFD model. And the last one, the phenomena that involve fluid flow. Okay, so the second point is the structure curl between steel AISI and titanium alloy. Okay, so for the thermal conductivity, for the steel AISI, we get around 60.2 W over mK, while for the titanium alloy, we got around 6.7 watt over meter per kilo. So this show that heat transmitted through a material for steel is more higher compared to the titanium. Okay, while for the structural comparison on the pressure, we can say that titanium get higher compared to the steel. The titanium can undergo more pressure, which the maximum is 1.695 E plus 0.9, while for steel is around 1.121 E plus 0.9 kilopascal. Okay, so this can be concluded that titanium alloy have a better on structure, fluid flow, and thermal mechanical equipment. That's all from me. Thank you.